Okay, first I'm going to start off by paying a little contribution or respects to this man here in the middle. That is my grandfather, and he is actually the reason I am not in school or was not in school yesterday or will be today. He passed away on Friday, so we are celebrating my family and I are celebrating his life Monday and Tuesday. So I will be back Wednesday, but just so you know, that's where I'm at. Um, So let's first, so you took a quiz yesterday on 2.4. We're skipping 2.5 and we're moving to 2.6. 2.6 is all about factoring, so I feel like we need a big factoring review before we can really go into this lesson. So we need to know that ax squared plus bx plus c equals 0. That is standard form of a quadratic equation. Pretty much where the underscores are here, or the underlines, whatever you want to call them, that's where you put the factors of your a, because what times what gives you that a x squared term, that quadratic term. So we'll practice those. And the question marks here are your factors of c that you would have to fill in there, that when you check your OI, the outside terms multiplied by the inside terms, when you check your OI, it's going to total your B term there, your middle term. A couple rules to follow. If C is positive, it means your signs are going to be the same. They will either both be positive or both negative. You have to look at your B term to identify which of that will be. If C is negative, your signs will be different, and to know which one's positive or negative just depends on the value of the sign and the context of the problem, to be honest with you. And then I already established this, but make sure you check your OI. Now you will see some answers up here, and that's because I had already spent like 15 minutes creating this video, and then for somehow it like just erased. Not sure how that happened. So I'm going to go through them again, and yeah, we'll have you take your notes on it. So anyway, for this first problem, we have x squared minus 7x plus 18. That is a quadratic expression. It's not an equation because it doesn't have equal 0, but you can factor quadratic expressions as well. The only difference is we're not going to have to actually solve these equations by factoring. We will in our lesson, but I'll review that when I'm back tomorrow and we start 2.6. Okay, so factoring here, it's ax squared. So in this case, my a is a 1. So it's nice because I can just do 1x times 1x. That's going to be the first term in each set of parentheses. And the signs here are different. So that means one sign is going to be positive and one is going to be negative. It doesn't matter which one's which. What matters is where we put the factors so that when we check our OI, it's going to multiply to this negative 7. My factors of negative 18 are 1 and 18 and 2 and 9 and 3 and 6. I know just because I do fairly well with my multiplication facts that I am going to want to choose 2 and 9 because when I check my OI and I do negative 9 times 1x, I get negative 9x, and when I do 2 times 1x, I get 2x, and negative 9x plus 2x is negative 7x. Now, if you're not that strong with your multiplication facts, I firmly believe that you will get the right answers. It will probably take you a little bit longer because you're going to have to use a calculator, but you'll get there. And the more of these problems that you do, the stronger you will get with your multiplication facts. Okay, so first of all, these are all on your worksheet that you should have out in front of you. So copy these down for your notes. The evens will be your homework. To finish, and they will be due tomorrow. So let's move on to number 3. Again, a is a positive 1, so that makes things a little bit easier. So I know the first factor or the first term in each factor is going to be m times m, because 1m times 1m gives me m squared. The c term is positive, which means my signs are going to be the same. So I look at b, and that's a negative, so both of my signs are going to be negative. In this case, my factors of 8 are 1 and 8 and 2 and 4. And again, knowing that I have to check my OI, the 8 and the 1 are the values that are going to give me 9. So when I check my OI, m times negative 8 is negative 8m, and negative 1 times m is negative 1m. Negative 8 plus negative 1 is negative 9. So there is that quadratic expression factored. Number 5. Okay, so here my a is no longer 1, so it makes it a little bit harder, but it's 7 is a nice prime number to use because its only factors are 7 and 1. So those are going to be the first terms in each of, or the first term in each of my factors. So I do that, then I look, notice all the signs, or C is negative, so my signs are going to alternate. I am going to take a wild guess here and assume that because B is negative, that means 7 times the number here is going to be negative, because that's probably going to create a bigger number than 1 times anything would be able to create. So now I have to decide which factors to put here. Well, here are all of my factors of 20, 1 and 20, 2 and 10, 4 and 5. And just quickly, I'm going to think, what could give me 31? Well, 7 times 1 plus 20, that'd be negative 7 plus 20. That wouldn't. Let me try with my 2 and my 10. 7 times negative 10, that's negative 70. Negative 70 plus 2 is not even close. Or if I did 7 times negative 2, that's negative 14. Negative 14 plus 10, yeah, that's not going to work either. So I'm assuming it's 4 and 5, and I know that 7 times 5 is negative 35, and negative 35 plus 4 is negative 31. So when we check our OI, 7x times negative 5 is negative 35. 4 times x is 4x. Negative 35x plus 4x is negative 31x, which checks out. So that is essentially the same thing I'm doing here. How can I get 7x squared? Well, I can only do that by 7x times x. My signs, again, are C is negative, so again, my signs will alternate. My factors of 28 are 1 and 28, 2 and 14, 4 and 7. And I know that 7 times 7 is 49, or in this case, negative 49, when I check my OI. And negative 49 plus 4 is negative 45, which is what my B term is. So 7x plus 4 times x minus 7 is the answer there. I'm not sure what happened. What do we say this was? 7x plus 4 and x minus 7. Okay. Number 9, again, very nice that it's a 5p squared. So I know it's my only first factors can be 5p and p. They are both negative, or sorry, C is negative, so which means 1 is going to be a positive, 1 is going to be a negative sign. And my factors of 18 are 1 and 18, 2 and 9, 3 and 6. Just thinking here, 5 times negative 3 would be negative 15, and negative 15 plus 6 would not give me a negative 1. So I'm going to, and 5 times 6 would be 30, so that's not even close. So let me go to 2 and 9. 5 times 2, I know will give me negative 10p when I check my outside. And then 9 times p will give me positive 9. So negative 10 plus 9 is negative 1. So there is that quadratic expression factored. Move on to 11. You might say, well, hold on, that's not a quadratic expression. And you're right, it doesn't look like it is. But as you look closer, notice they all have a b in common. So we can factor that out. It's called factoring out the greatest common factor. So we factor that b out, which is the greatest common factor, and we're left with 3b squared minus 5b plus 2. So same kind of situation here. I want to factor. So if I keep the b out in front, and then 3b times b is how I'm going to get my, let me just delete this. So I keep the b out in front, and 3b times b is the first term in each of my factors. C is positive and B is negative, so that means my sign is going to be negative for both of these. And my only factors are 2 and 1, so I'm going to plug a 2 in and a 1 in and then check my OI. 3b times negative 2 is negative 6. Negative 1 times b is negative 1. Negative 6 plus negative 1 is negative 7. So I know these are the right numbers, but they must be in the wrong order. So let's try this. 3b times -1 is -3. -2 times b is -2b. So -3b plus -2b is -5b. That checks out. 13, same scenario. We have to take out the greatest common factor. What's nice a little bit about this, so we're not trying to write my factors at 30, is that this does again have a greatest common factor, and it is again b, but also it's a 3 because I can divide each of those coefficients by 3 and get a whole number or an integer. So when I factor out the 3b, I'm going to be left with 10n squared minus 29n plus 10, and then we can factor that quadratic expression. So again, how do we get 10n squared? 5n and 2n, and then what are my factors of 10? Well, c is positive and b is negative, so both of my signs are going to be the same, and in this case, they're both going to be negative. And then my factors of 10 are 2 and 5 or 1 and 10. And when I check my OI, 5n times -5 is -25, plus -2 times 2 is -4. -25 plus -4 is -29. So here is the factored expression for 13. Okay, 15, same kind of scenario. We have what looks to be a quadratic, but for some reason there's two variables. So if we look closely at all three terms, they all have r, so we can factor out that r, which I did here, leaving us with 9p squared plus 73p plus 70. And then we can factor this. Now my factors of 9p are of 9p squared are either 3p and 3p or 9p and 1p. And I'm going to go out on a limb here, and because of it being a 73p as our b term, I'm going to assume we are using 9p and p as the first coefficients in each factor. I might be wrong. We might have to go back and fix that, but we'll see. So in this case, everything c is positive, which means the signs are the same, and b is positive, so that means the signs are both positive. So now it's my factors of 70, so I have those here. 1 times 70, 2 times 35, 5 times 14, 7 times 10. I think that's all of them. And so now it's a matter of finding which of these I'm going to use to plug in here. And I think it's going to be 7 times 10 because, again, just thinking a little bit, if I would plug a 7 in here, I would have 63 because 9p times 7 is 63p. And then 10 times p is 10p, and 63p plus 10p is 73p. So there are your two factors, or three factors, r 9p plus 10 times p plus 7. So there is that quadratic in factored form. On to 17, we have 4x to the third plus 43x squared plus 30x. Again, you might say, well, no, that's not a quadratic, which you're right, it's not, but it can be as soon as we factor out the greatest common factor, which is x. And it doesn't look like there is any other greatest common factor, like 2, because yes, 30 and 4 are both divisible by 2, but 43 is not. And if it's not divisible by 2, it's not going to be divisible by 4. So we'll have 4x squared minus 43x plus 30. And again, it's okay, so my factors of 4 are either 2x and 2x or 4x and 1x. Again, because my b term is 43, I'm going to hope that I'm going to try 4x, and we'll see if that works. C is positive, so that means the signs are the same. B is negative, so that means they are both negative. And my factors of 30 are 1 and 30, 2 and 15, 3 and 10, and then 5 and 6. So which of these do I think I can plug in here and get 43? I don't think 5 and 6 will work. I think 3 and 10 will, though, because 4x minus, or 4x times -10 would be -40, and then Negative 3 times x would be negative 3, so negative 40 plus negative 40x plus negative 3x is negative 43x, which is what we need. So there we have, oh shoot, that's supposed to be a plus, 43x. So the only thing that changes is all of these signs are positive. So yep, still checks out for us. So those are your factors. 19, what it's asking us is, for what values of b is the expression factorable? So, I mean, the solutions to this are not endless. There's, I guess, a definite answer. So let's look back at this. What factors of b would make this work? Well, my only factors of 12, let's figure that out, are 1 and 12, or 2 and 6, and then we have 3 and 4. So if I would plug those in there and check my OI, I would think b could equal positive 13 or negative 13. Oops. Because 12 and 1 would be 13, and then negative 1 and negative 12 would be negative 13. 2 and 6, so it could be 8 and negative 8. And then I believe we could have 7 and negative 7. I'm pretty sure all those values will work. So if you might be able to find more, maybe not, or maybe you found that I was wrong on one of those when you try it yourselves, which is fine. I'm human too, I'll make mistakes. So like I told you at the beginning of the video, the evens are your homework, and these questions will be collected. I expect to see work. You might say, well, hold on, you didn't have much work. You're right, I didn't have much work, but I had work. I wrote my factors of my C term. I didn't really have to necessarily write the factors of my A term because most of the time they were prime numbers, so there was only one option. I showed where I factored out the greatest common factor. So basically be prepared to walk through it, like how you could get that factored expression, kind of using these rules here. You checked your OI, you knew that it was C was positive, so that means they were the same sign. Like, just be prepared to explain your process on Wednesday. So I will see you tomorrow. Please be good for the sub, and if you have any questions, the sub probably cannot help you, but hopefully someone else in the classroom is available. Thank you, and have a good day.